Welcome to Astronomy Daily, your daily space and astronomy news roundup. I'm your host, Anna, and today we've got an exciting lineup of stories covering everything from SpaceX's headquarters move to mysterious dark comets and volcanic moons. So let's get started. In a significant development for the space industry, Elon-musk has announced that SpaceX's headquarters will officially relocate to Starbase-Texas. This move follows a pattern we've seen from Musk's companies, with both Tesla and X, formerly Twitter, having already made similar transitions away from California. The relocation to Texas marks a substantial shift in SpaceX's operations, though the full extent of job and facility transfers from California remains unclear. The company has already been expanding its presence in Texas, with substantial operations at its Boca Chica facility, now known as Starbase. This decision aligns with Musk's previous business moves, including his personal relocation to Texas in 2021. The state's business-friendly environment and absence of state income tax have made it an increasingly attractive destination for tech companies and their executives. Scientists have made an intriguing discovery in our cosmic neighborhood, identifying 7 new dark comets, bringing the total known count to 14. These mysterious celestial objects are challenging our understanding of what makes a comet, as they display some rather peculiar characteristics. Unlike traditional comets that sport their iconic tails, these dark comets remain visually elusive while still exhibiting comet-like movement patterns. What makes them particularly fascinating is that they show non-gravitational acceleration, meaning something besides gravity is influencing their trajectories, yet they lack the visible outgassing we typically associate with comets. The research has revealed 2 distinct families of these enigmatic objects. The first group resides in the outer solar system, sharing space with our gas and ice giants. These outer dark comets are relatively large, measuring hundreds of meters across, and follow more elliptical orbits similar to typical comets. The second group, found in the inner solar system, consists of smaller objects just tens of meters across, traveling in more circular orbits like our planets. This discovery could have significant implications for our understanding of Earth's early history. Scientists suggest that as many as 60% of near-Earth objects might be dark comets, potentially playing a crucial role in delivering water to our planet during its formation. Here's a story for our listeners in Australia. The Geminid Meteor Shower will be putting on a dazzling celestial display this weekend, treating stargazers down under to one of the year's most spectacular astronomical events. Unlike most meteor showers that come from comets, the Geminids originate from an unusual asteroid called Phaethon, which occasionally behaves like a comet by producing a dusty tail. This unique characteristic of Phaethon results in the Geminids producing some of the brightest and most robust meteors of any annual shower. The meteors occur when Earth passes through the debris trail left behind by this mysterious asteroid, with the particles burning up in our atmosphere at speeds of tens of kilometers per second. While this year's show coincides with a full moon, which can somewhat diminish the visibility of fainter meteors, the Geminids' characteristically bright nature means that many shooting stars should still be clearly visible. The best viewing will occur in the early morning hours of Saturday, particularly around moonset, when the sky is at its darkest. You can find plenty of charts online that can advise you of when moonset is happening in your area. For optimal viewing, astronomers recommended finding a spot away from city lights and focusing on the area between Mars and Jupiter, just below the star Pollux in the Gemini constellation. However, meteors could appear anywhere in the night sky, making a wide field of view more advantageous than using specialized equipment like telescopes or binoculars. Happy stargazing. Next up, in an exciting discovery that's challenging our understanding of planetary systems, researchers have identified a 4th planet in the fascinating Kepler-51 system. This star system was already unique for hosting 3 ultra-low density planets known as superpuffs, worlds that are about the size of Saturn, but only a few times more massive than Earth, giving them the density of cotton candy. The discovery came as a surprise when scientists were observing Kepler-51d with NASA's James Webb Space Telescope. The planet transited its star 2 hours earlier than predicted, suggesting something was tugging on it gravitationally. After analyzing data from multiple telescopes, including Webb, Hubble, and ground-based observatories, researchers confirmed the presence of this previously unknown fourth planet, now designated Kepler 51e. The new planet appears to orbit its star every 264 days, placing it just inside the star's habitable zone at a distance slightly greater than Venus is from our Sun. While researchers aren't certain if this new world shares the superpuff characteristics of its siblings, its discovery is forcing astronomers to rethink their theories about how such unusual planetary systems form. This finding is particularly intriguing because superpuff planets are quite rare, and when they do occur, they're typically the only one in their system. Now we have a system with at least 3 confirmed superpuffs, possibly 4, making Kepler 51 an even more exceptional case for studying these mysterious cotton candy worlds. Talking of new discoveries, a concerning new study suggests that our sun might be capable of producing massive solar flares, known as superflares, far more frequently than we previously believed. According to research that surveyed over 56,000 sun-like stars, these powerful eruptions could occur as often as once every century, rather than the previously estimated time frame of many hundreds to thousands of years. These superflares can release energy between 100 and 10,000 times greater than the largest solar flare ever measured from our sun, the famous Carrington event of 1859. This is particularly noteworthy because it's been about 165 years since that last major solar storm hit Earth, potentially putting us in line for another significant event. If such a superflare were to occur today, the consequences could be devastating for our modern technology-dependent society. These events can potentially knock out communication systems and power grids, causing widespread disruptions to our daily lives. The research team, led by scientists at the University of Oulu in Finland, detected nearly 3,000 superflares across more than 2,500 stars during their survey. While scientists are still uncertain whether our sun behaves exactly like these other stars, this research raises important questions about our star's capability for producing such powerful events, and highlights the need for better preparation and protection of our vital infrastructure against potential solar storms. And in other discovery news, scientists have made a fascinating breakthrough in understanding one of our solar system's most active worlds. NASA's Juno mission has finally solved a 44-year-old mystery about Jupiter's moon Io and its extraordinary volcanic activity. Through extremely close flybys that brought the spacecraft within just 930 miles of Io's surface, researchers have discovered that each of its estimated 400 volcanoes is likely powered by its own chamber of molten magma, rather than a global underground ocean of magma as previously theorized. This volcanic activity is driven by an intense process called tidal flexing. As Io orbits Jupiter every 42.5 hours, the gas giant's immense gravitational pull literally squeezes and stretches the moon. This constant manipulation generates tremendous internal heat, melting portions of Io's interior. By measuring how the moon's gravity affected Juno's acceleration during its flybys, scientists were able to determine that Io's interior structure is more rigid than would be expected if it contained a global magma ocean. This discovery not only changes our understanding of Io, but has broader implications for how we think about other moons in our solar system, such as Europa and Enceladus, as well as exoplanets beyond our solar system. It provides new insights into planetary formation and evolution, showing how complex and varied volcanic processes can be across different worlds. And that's all for today's space news. I'm Anna, and you've been listening to Astronomy Daily. For more fascinating stories from the cosmos, head over to our website at astronomydaily.io, where you can catch up on all the latest space and astronomy news with our constantly updating newsfeed. Listen to all our back episodes and sign up for our free daily newsletter. Don't forget to follow us on social media. You can find us as Astro Daily Pod on Facebook, X, Tumblr, YouTube, and TikTok. Until next time, keep looking up and see you tomorrow.